Okay, now here we have king of questions. Question is in the form of paragraph, and based on this paragraph we have two questions. Question is, let psi1, psi2, f and g are functions from this interval to set R such that f of 0 is equal to g of 0 is equal to 0. Function psi1x is e power minus x plus x. Function psi2x is x square minus 2x minus 2 into e power minus x plus 2. Functions fx and gx are in the form of integrals. Okay, function fx is integration of modulus of t minus t square into e power minus t square. Lower limit is minus x, upper limit is x. Function gx is integration of root t into e power minus t, where lower limit is 0 and upper limit is x square. In both the functions, x is greater than 0. Now we have two questions, and this is a nice way to form the question. We have two options for psi1 and psi2 in one question, and two options in the other question. And for functions fx and gx, we have two options in one question and two options in the other question. Let's first examine functions psi1 and psi2. We have two options in question 1. For all x greater than 1, there exists alpha belongs to open interval 1 to x such that psi1 x is equal to 1 plus alpha x. And for all x greater than 0, there exists beta belongs to interval 0 to x such that psi2 x is 2x into psi1 of beta minus 1. Okay, and two options here. Psi1 x is less than or equal to 1 for all x greater than 0, and psi2 x is less than or equal to 0 for all x greater than 0. So let's first examine functions psi1 and psi2. We have psi1 x is equal to e power minus x plus x. To examine or study this function, we study its derivative. Let's check the trend. We have derivative of psi1 x is equal to 1 minus e power minus x. Okay, and clearly this belongs to open interval 0 to 1 for all x greater than 0. Okay, for x greater than 0, we have 0 less than x less than infinity. We have minus infinity less than minus x less than 0. Okay, then we have e power minus infinity less than e power minus x less than e power 0, means 0 less than e power minus x less than 1. Okay, then we multiply each side by minus 1, we get minus 1 less than minus e power minus x less than 0. We add 1, we get 0 less than 1 minus e power minus x less than 1. Okay, so expression 1 minus e power minus x belongs to open interval 0 to 1 for all x greater than 0. Now with this finding, we can reply for this option 1b and this option 2a. Here psi1 x is less than or equal to 1 for all x greater than 0. Derivative of psi1 x is positive for all x greater than 0. That means a function psi1 x is an increasing function for x greater than 0. Okay, so for x greater than 0, we have psi1 x greater than psi1 0. Okay, psi1 0 is 1. Okay, so we have psi1 x greater than 1 for all x greater than 0. So this option is false. Here psi1 x is less than or equal to 1, but we are getting psi1 x more than 1. So this option is false. Okay. Okay, then we have this option for all x greater than 1, there exists alpha belongs to open interval 1 to x such that psi1 x is equal to 1 plus alpha x. If this holds, then graphs of y is equal to psi1 x and y is equal to 1 plus alpha x will intersect at least once for x greater than 1. Okay, so what do? We draw the graphs of these two functions. Here we have coordinate axis. Okay, psi1 0 is 1, so we mark here point 0 comma 1. Okay, then psi1 x is an increasing function for x greater than 0. So we have this rough sketch for function y is equal to psi1 x. Then we have this variable straight line. for alpha greater than 1. This line always passes through point 0 comma 1. Okay, take any value of alpha, line always passes through point 0 comma 1, but slope of line is more than 1. Okay, so we have here different lines having slope more than 1. Okay, and definitely this lines will lie above this graph, because at any point on the graph slope of tangent will be less than 1. Okay, and these lines have slope more than 1, so definitely these lines will lie above this graph. That means these lines won't intersect this graph for any value of alpha. Okay, that means this equation has no root. That means this option is also false. Okay, now we have two options for psi 2, this and this. Here psi 2x is less than or equal to 0 for all x greater than 0. So we study function psi 2x, we find its derivative. Derivative of psi 2x is 2x minus 2 plus 2 into e power minus x. Okay, and this is 2 multiplied by x plus e power minus x minus 1. Now this is very nice question. The reason is all the functions are connected. Like here this is psi 1 x minus 1, and just now we proved that psi 1 x is greater than 1 for all x greater than 0. Okay, that means this is greater than 0. Derivative of psi 2x is positive, so psi 2x function is also an increasing function. For x greater than 0, we have psi 2x greater than psi 2 0. Okay, because function psi 2x is an increasing function. So from this we get, what is psi 2 0? Put here x is equal to 0, we get 0 minus 0 minus 2 plus 2 0. Okay, that means psi 2x is greater than 0 for all x greater than 0, but here we have psi 2x less than or equal to 0, so this option is also false. Okay, okay, now we have this option: for every x greater than 0 there exists beta belongs to 0 to x such that psi 2x is 2x into inside brackets psi 1 beta minus 1. Now from this, derivative of psi 2 at x is equal to beta will be 2 into inside brackets psi 1 beta minus 1. We have here this derivative. Okay, that means we have to check psi 2x is equal to x into derivative of psi 2x at x is equal to beta. Okay, now we can use LMVT, Lagrange's mean value theorem. Okay, using LMVT we can say there exists beta belongs to open interval 0 to x such that psi 2x minus psi 2 0 over x minus 0 is equal to derivative of psi 2x at beta. Okay, and psi 2 0 is 0, this is 0, so from this we can say psi 2x is equal to x into this. Okay, that means this statement is true using LMVT, Lagrange's mean value theorem. Okay, so this option is correct. Now when you find this option correct, there is no need to check these two options because this question was asked in single correct answer type. Okay, but even then we will check all the options. Okay, now we have options for functions fx and gx. We have two options here and two options here in second question. Let's first check this option. Function fx increases in the interval, closed interval 0 to 3 upon 2. For that we need to find derivative of function fx. Look at function fx. Clearly this function is an even function. Okay, so using the properties of definite integrals, we have fx is equal to 2 multiplied by integration of t minus t square into e power minus t square with lower limit 0 and upper limit x. Okay, here x is greater than 0, so there is no need to put modulus when you have these limits 0 to x. Okay, and function gx is this. Let's first analyze function fx. we find derivative of fx. Derivative is 2 into x minus x square. We are using Leibniz rule, okay, into e power minus x square. This is 2 into x into 1 minus x into e power minus x square. We use sign scheme method to check the sign of derivative. We have critical points 0 and 1. Signs will be minus, plus, minus, because here coefficient of x square is negative. Here coefficient of this x is negative, okay. So function increases here in the interval 0 to 1, okay, but here interval is 0 to 3 upon 2. So definitely this option is false, okay. जो simple option है हम उसको पहले check करेंगे, okay. So this option is rejected. Then we check this option. Here we have f of root log 3 plus g of root log 3 is equal to 1 upon 3. That means we have to find the value of fx plus gx at x is equal to root log 3, okay. Now to get this function, to add fx and gx, we need to have same limits. Here limits are 0 and x. Here limits are 0 and x square, okay. We can get limits 0 and x by replacing t with t square. In this replace t with t square, we find gx is equal to 2 multiplied by integration of t square into e power minus t square, having lower limit 0 and upper limit x. Replace t with t square, we find gx is equal to this, okay. Now we add fx and gx, we get fx plus gx is equal to 2t into e power minus t square, integration of this function, okay, having lower limit 0 and upper limit x, okay. Next we can integrate this. Derivative of minus t square is minus 2t, so integration will be minus e power minus t square, okay, having limits 0 and x, and from this we find this is equal to 1 minus e power minus x square, okay. And then we put here x is equal to root log 3. We find this is equal to, putting x is equal to root log 3, we find 1 minus e power minus log 3. This will be 1 minus 1 upon 3 using properties of logarithm. So this will be 2 upon 3. So this option is false, okay. Now let's check these two options, okay. Now for this option we consider function fx. We have fx is equal to integration of 2t into e power minus t square minus integration of 2t square into e power minus t square. Lower limit is 0 and upper limit is x. This is we just got the value of this. This is 1 minus e power minus x square. We are getting this expression here, okay. And here to integrate this we use expansion formula. Definitely this is non-integrable because here we have t square, okay. So we use expansion of e power minus t square. We get 1 minus t square upon 1 factorial plus t power 4 upon 2 factorial minus t power 6 upon 3 factorial, okay, plus t power 8 over 4 factorial and so on, okay. Now we integrate this with this limits. We find fx is equal to 1 minus e power minus x square minus 2x cube over x plus 2x power 5 over 5, okay. Then we will have minus x power 7 over 7 plus 1 upon 3 into x power 9 over 9 and so on, okay. And definitely this will be less than 1 minus e power minus x square minus 2x cube over 3 plus 2x power 5 over 5, because expression from this term onwards will be greater than 0 for x belongs to 0 to 1 upon 2. आप check कर सकते हैं, this expression will be positive. Okay, so we are getting fx less than this, but here fx is greater than or equal to this. Okay, so definitely this option is false. Okay, then definitely this option will be true. Let's check this option. And for this inequality, we evaluate this integral. We have gx is equal to, replace t with t square, we find integrand 2t square e power minus t square with lower limit 0 and upper limit x. Okay, now use expansion formula of e power minus t square. This is 1 minus t square over 1 factorial plus t power 4 over 2 factorial minus t power 6 over 3 factorial plus t power 8 over 4 factorial and so on. Okay, now we integrate, we find gx is equal to 2x cube over 3 minus 2x power 5 over 5. Okay, then we will have plus t power x power 7 over 7. Okay, and then some expression in x. Okay, and we find that for x belongs to 0 to 1 upon 2, this expression will be less than 2x cube over 3. In fact, less than or equal to, we can put equal to sign also, minus 2x power 5 over 5 plus x power 7 over 7. Okay, so we have gx less than or equal to this for all x belongs to open interval 0 to 1 upon 2. Okay, so this option is true. So in this question option C is correct, and in this question option D is correct.